Hello, welcome to the today's session. In today's session, we will discuss about the projection of solids, in which we will see how the right circular cylinder is oriented in such a way that we will obtain the projection of the right circular cylinder, which is inclined to HP in the first stage, and later on, which is inclined to the VP in the second stage. So let us discuss the problem and we will solve it step by step. So in the question it is mentioned the right circular cylinder diameter of base 50 mm and axis height 70 mm has one of the circumference point of base in HP such that its axis is inclined at 30 degree to HP and axis appear to be inclined at 45 degree to VP in its top view. So first we will draw the projection of the right circular cylinder below the XY line, because in this case in the first stage it is mentioned that the axis is inclined to the HP. So first we will draw the circle having a 25 mm radius, that is the diameter in this case is 50. Then we will take its projection, which will be seen as a rectangle, and later on we will incline it by 30 degrees so that one of the corner of the base, that is one of the circumference point of the base, is inclined at 30 degree to HP. So let us divide the circle into the 8 equal parts by joining the point on the circumference with the point on the center. And then for dividing the circle into the 8 equal parts, we will use the polar array. So let us click on the polar array. Select this line which is drawn. Then we will select the center point. We can see that by default the 6 number of parts the circle will be divided into. Now we shift the number of items to be 8, right, and we close the array. So for simplification we will give the numbers to this for the each equal part, giving the numbers as 1 to 8. 1. Let us increase the height of the text to 5. Then we will little bit closer to the positioning. Let us click it like this. Okay, and then we will copy this for the placing at the appropriate numbers like this. And later on we can change it. So let us rename this as 2. Let us rename this as 3. This as 4. This as 5. This as 6. This as 7. And this will be renamed as 8. Now we obtain the projection of each this division into the front view. So let us take this projection of 1, switch on the ortho mode along with the O snap. So then let us take this projection till here, right? Let us take the height of this as 70, which is as per the question. Then let us take it the point from the 5 like this, and then we complete its projection here. Okay, now let us take the projection obtained from the 2,8 like this. Okay, similarly the projection obtained from the 4,6 like this, and then let us show the axis. For that we load the type of line center from the this drop down menu of the line types. We will also load the dotted line, which will be required later on. So which is sometimes called as hidden, or we can also load the dash line. So let us click on the dash line and the hidden line. Both will be very much same. So let us load the hidden line. and click on OK. Now let us take the center line and then we will project it like this. Now if we think that the distance between this large line and the short line, or the gap between the long line and short line is very large, then we can change the line type, or we can change the scale, in this case LT scale. So LT scale in this case is default will be 1, so we can change it to, let us say, 0.6, and let's check whether that distance looks to be appropriate. If it's appropriate, we can proceed. Okay, we can see that. Now we transfer these projections names into the front view. So we can delete this if required, right? So now copy this here. So this will be named as 1 dash. Then copy this. So this will be renamed as 2 dash comma 8 dash. 2 dash comma 8 dash. This is the projection obtained for the 3 comma 7. So which will be renamed as 3 dash comma 7 dash. Then this is the projection obtained from the 4 dash comma 6 dash. So let us copy again. And the last projection that we obtain it for 5 dash. So which we have kept it and we will rename it later. So this is 4 dash comma 6 dash, and the last projection is obtained for the 5 dash, and we will delete this 7 dash. Okay. So in this way the projections are obtained. Just for reference, we will keep the end projections. For that we need to change the line type again to continuous. So let us click on this. Then this. Okay. Same projections will be also, or the same annotations will be also kept for the top base. So copy in this way for the top. Now let us increase the line weights. For that we will redraw this top base and the bottom base if required. So here we have redrawn the bottom base for making it thick. So let us select the line type, in this case as continuous, and the default thickness we will let us take it as 0.9. Now let us select this circle and now change its thickness to 0.3. We see that it is not appearing thick because in this case the line weight display is not on. So now we have switched on it. Now let us select this match properties and let us select all the edges of this rectangle in this way. So this completes our first stage. Okay, or we can say that it is the front view and the top view for the first part is completed. Let us give the dimensions. So in this case the dimension is 70, and for this let us give it the diametrical format. Okay, if we want to change the orientation of this 50 such that the leader line appears, for that we go to the annotations tab and we select on this dimension style manager, the shortcut for which is dim style. Now we go to the modify. In this we change the text type to the 3. Let us take. Then we can change the arrows to 3. Okay. Then in the text placement, in the text alignment, let us keep it the ISO. Let it be above, and we can change the offset from the dimension line as 1. Then we go to the primary units. We can switch off the precision to 0 and this decimal operator as period. We click on OK, and then we do it as set current. and click on OK. So we can see that this leader line appearing automatically for the dimensions provided, and this arrow is also made little bit larger, that is having a dimensions 3. Now in the seconds, that is the third step, what we need to do, we need to incline the base in such a way that it is appearing axis needs to be inclined at 30 degree to HP. So let us click on this. Now we copy this along with its base. So I do not want the dimension to be again copied. So let us select only this 1 dash and 1 dash without keeping these dimensions. So let us copy. Let us take the base, and in this way it is copied. So do it again. Copy. Okay. Now once it is copied, let us check whether it is a continuous line or center. We want it at center. So this also we want it at center. So this is center line. Now we again select it. We also want this bottom annotations. So again we do it copy. We see that whether the all annotations are getting transferred into the copied object. Yes. Okay. Then we shift this line type to the center line. Now we select this again and we place on the rotate, and then we can select this phi as the corner, which is nothing but the point on the circumference, and in this case the axis needs to be inclined at 30 degree to HP, so that in this case the base will be inclined at 60 degree. So now we give the angle. Here we can see that we need to mention the rotation angle. So in this case we give the rotation angle as minus 60. So in this case automatically the angle between the axis and this XY line will be maintained as 30 degree. See this. Now we obtain the projections in the top view by using this line command or the projections. Let us see this. So point we take. So this is for us 7, and let us start our projections from the 1. So 1 is here, and this is the projection for 1. So this is the first point that we obtain. But we see that whenever we see the point, it is very small. So for to change the point type, we type the command as p type, and we select this, which is a better option for displaying the point, and we set the point size as let us say 3, and we set the site says set size in absolute unit, which is nothing but 3 in this case, so that the size of the point will be fixed even though we are zooming in or zooming out of the screen. So we see that this point is now appearing larger, and this point will be renamed as 1. So let us 1 keep it here 1. Similarly we obtain the projections for 2, 8, 3, 7, 4, 6 and 5. So we take the point again. Let us take it for the 2. So this is the point 2. Then let us take it the point for 3. 3 is on this. So this is the point 3. Let us take it the point 4. This is the point 4. Let us take it the point 5. Now before proceeding we will give the name so that later on the things should not get complicated. So this 2. Let us copy the 3. Let us copy the 4 and 5. Okay, then let us take the point 6. For that, again we take the point. So 4 and 6 will be on the same vertical line. Then let us take the point 7. So this is the point 7. Let us take the point 8. So this is the point 8. Okay, so we give the names in this case. This 6, 7, 8. Okay, now we draw the projection for the center line for reference, just like this. And in this case, we also showed it this. Okay, so now we use the ellipse. Now in this case, we know the center. So let us select the center. We know in this case the axis endpoint. So we select this, and this is our another axis endpoint. Now let us take the projection, and let's see, this we will be copied. So for that, we draw the center line from this. So this is our center point, right? And we see that this object is symmetrical. So whole this copy will be done here, taking this as a center point. So copy in this case. Now we want the points to be also copied. So let us select the points also. So in this case, we select this along with it. So copy this. In this way, we have created the ellipse here also. Now, whenever we look at this cylinder from the top, we see that this base is completely visible. So this will be darker, but for this base, we will be only seeing the base from 1 to, that is for 1, 2, 3 and 187. So only this much is the part of the base will be visible. So on this side, and this part of the base will not be visible. So we will have to trim it. So let us trim it. This part is trimmed, this part is trimmed. And then what we will do, we will overlap it again on this side, or what we can do, this needs to be moved. So let us move this base to some another suitable place. So let us take it here, and we will draw an ellipse by taking the hidden line. So let us take the ellipse here. This is our center point. So let us select the center point. Let us select the end point, and this. Now this is the part which we wanted, and these parts needs to be removed because it is the part of the ellipse is visible, part is not visible. So let us trim this. Okay. Now this will also be needs to be moved back to its original place. So let us move it. So this is the center point of the moved part. Now let us place it here. Okay. So now we join this 7 to 7 by using a line like this. For that, we need to change the line type to continuous. So let us join this 7 to 7, and let us join this 3 to 3. Okay. Now we will make this edges of this bottom part, that is the projection, as thicker. So let us select this, match properties, this, 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 and this. Let us keep this as dotted. Now we proceed towards the second stage, that is the step number 5. For that, we copy this. One also needs to be copied. So now before we proceed, what we need to do, we need to show the center line. So let us draw a center line from this point to this particular point. For that, we will trim this again. Let us redraw the center line for reference. So this is our center line. Okay, so this also needs to be trimmed off so that it better looks like a center line. You can see that this is a center line. Now if you wanted to change the scale, again we can use the LT scale. So in this case 0.6 is there, so let us keep it as 0.4. Okay, so we say that this is center line appear to be better now. So for greater visibility, let us move this one to here, close to this point. So let us move this one also to here. Let us move this 8 closer to the point. Okay, let us move this 8. We need to switch off the snap mode. Okay, let us move this 4 closer to the point. In this case, let us move this 4, 5, 6, 7. So move. Okay. Now we copy this. So we copy this. Now let us take the base point, switching on the snap mode again. We can switch on the ortho mode, right? Now, as per the question, now this axis appears to be inclined at 45 degree to VP. So we need to incline this axis by an angle 45 degree. So let us click this copied object. Okay, and then rotate. So in this case, this is our base point. Now we give the inclination to this so that the axis inclines by an angle 45 degree like this. Now some of the points which are crossing the XY line, we need to move this below. So move. Okay. Now we take the sum of the projections. Again we will use the minimum number of the projections so that objects looks clear. So let us start with our point 1 and let us take the point here. So this is the projection obtained from the point 1 and this is the intersection of this. So this is our point 1. Now let us take the point 2. So this is the projection obtained from the point 2. Let us take the point 3. This is point 3. Let us take the point 4. This is the point 4 and this is point 4. Okay. Let us take the point 5. The point 5 is on the base. This is point 5. Let us take the point 6. 4 and 6 will be on the same horizontal lines. So this is point 6. Let us take the point 7. 3 and 7 on the same horizontal line. So this is point 7. And then finally the 8. 8 will be on the horizontal line that is obtained from the 2 and 8. So now let us give the names. So this copy this, or let us copy this 1, copy this 1. So we see that this is our projection of 1 dash. This is our 1 dash, which is nothing but not this point but here. So this is our 1 dash. Then we copy this, copy. So this 1, this is now our 2 dash. So let us give it the name as 2 dash. This is 2 dash. So now copy this, or what we can do, we can make one multi-line text. In this case, let us keep it at 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash. Let us keep the size of all as 3 or 5. Let us keep it as a 5, right? And then select all, and then let us click it on the explode in this case. So all are separated now. So we wanted 3 in this case. So move this 3. So now 3 is here. Let us move the 4. So this is our 4 dash. Let us move the 5. 5 dash is here. Let us move the 6. This is our 6 dash. Let us move the 7. This is our 7 dash. Let us move the 8. This is our 8 dash. Now whenever we look at from this side, we see that all the points of the base are visible. So we will join it by using a spline, right? Now why we need to use the spline? Because in this case the center point is exactly not known. So let us look at the center point also for just for a reference. So this is our center point. So let us look at the center point in this case and try to join it with the spline, and let's see if it is looks okay or not. So this is our center point, and then this is one of the axis. Let us take. So in this case the 3 was here, which is nothing but the axis endpoint, but as the ellipse gets shortened in this case, so in this case it is, this will be the 4, and we see that this will be the joining. So we see that some of the points of the ellipse are not get joined. So the ellipse method we cannot use in this case. So what we have to do, we select the continuous line, we select the 0.09 as the thickness, and in this case we will take it the spline fit command, and we start with the, let us say 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, and then let us click it and then stop. Now in this case we will have to trim it like this. Okay, so in this case we might have to edit it like this. So now by looking at the points we can trim it very cautiously. This we need to trim off. We see that whenever it's showing, some of the lines get trimmed off automatically. So let us redraw this 4, 5, 6. Okay, so let us trim it. Okay, and then let us trim it. So this we get it the ellipse for the bottom side. Now let us thick it by using the line weight display. So this is, again we do it for this part, match properties, this case. So it is not the exact ellipse, but it is a spline that we do here. So we may pass it through the different points, but in this case only option available is to use the spline command rather than using it a spline command. Only option used to spline instead of the ellipse. Now let us locate it for the top also. So in this case we see the points 1, and let us transfer it using the point commands. So this is 1, and this is the projection for the 1. Then let us take it 2, 2. Let us take this 3. This is our point 3. Let us take the 4. This is our 4. Let us take the 5. Let us take the 6, which is nothing but the same horizontal line projection obtained from the 4 dash comma 6 dash, and vertical projection obtained from the top base of the bottom view. Then let us take it the 7, which is nothing but on the same horizontal line of 3 and 7. Okay. Then let us take the 8. This is for 8. Now let us copy these points along with its annotations. We can give the numbers to this in the same sequence as here, right? Let us copy just like this, or we may have to move it little bit to appear it closer to the points. So copy. Okay. So this is little bit closer. 7 is little bit closer. 8 is here. Okay, in this way we made it. And let us join the center line here, or this we copy. We need to locate the center also in this case. So this is the center, right? Now we copy this, copy from the center and place it. Now we see that the part of this only spline is appeared. So let us trim it this part by joining this line. Because part of this spline is not visible whenever we look at from the base. So this needs to be removed and this will be seen as a visible line. So let us copy this, copy this. Okay. So now this needs to be edited. We see that how we can edit. This way we can edit. So that this spline passes through the required lines or the required points. We are editing it like this. Okay. So now we trim it. This is in this trim option, but in this case we see that the line gets trimmed off. So what we do, we extend this, right? Now we trim it. So this needs to be edited. Okay. Okay, this needs to be trimmed. Now in this case this part needed to be drawn as a dotted line, because whenever we look it from this side, this 7 to 8 to 1 to 2 to 3 is not visible, right? So we need to draw it as a dotted line. So let us take this spline by selecting this hidden option and join it like this. We might have to use the control vertices to edit it. So that it looks like an ellipse. Trim, trim. Okay. So we see that it may not pass through exact vertices. So we might have to use spline fit edit option like this. And then let us join it. This edges. Let us see this center line. For that, we switch on the continuous line again. So we see where is the this spline option. So tangent option. So switch off all the options. And this case, this is our tangent option, and this is the tangent. Similarly, on this side, where is the tangent option we have to see. Okay. So we need to click on again. This is a tangent option. Now we see that it is not perfect tangent in this case. So this we obtained like this. Okay. So we might have to little bit strive for getting the perfect tangent. Now let us select this properties and let us select the match properties to select the this thickness part, right? And here we might have to stretch this to meet it. Let us edit this center line tangent and keep it posted nearer to the tangents like this. Okay, so in this way this is completed. Thank you.